My name is Robert Ping. I'm actually the manager of education outreach and training, and I work with Therese, who is my director, and she asked me to help set up this meeting with Eva. So many times, if you have something around campus that you would like to have scheduled, whether it's I can come to your department, I can schedule meetings with specific faculty, and I usually bring some experts with me. So that's exactly what we did today, because my background is actually education and music and event planning. So not a technologist, but I do work in research technologist, but I help try to connect people, which is exactly what we're doing today.
Therese Miller, Program Director, Collaboration Engagement, UITS Research Technologies. I work with all these wonderful people. We're over at 10th and the Bypass in the Cyber Infrastructure Building, right next to the data center. And if y'all haven't been over to the data center yet and you'd like a tour or would like to come visit us, we'd be happy to arrange that. We try to look at this presentation today, and we've tried to put together some slides and some information that we feel would be useful to your particular areas. There are a lot more slides in the deck than we'll actually show today, but hopefully that'll help give you additional information if you want it about any particular area that we're going to talk about. And you would introduce yourself.
They did.
All right.
Good to go. So I think what Robert and I talked about is that you'll probably just want to do the agenda slide and then turn it over to Robert and let the other folks.
Oh, sure.
You want to do that?
Yeah, we can do that. So this is the agenda we put together for today's. At the next slide, Robert. Yeah. Basically, Eva and I worked on it. We kind of tried to look at everything that we thought would be of value or interest. So the first slide, the first area on here we're going to talk about is high performance computing. Robert.
Oh, hi.
I think, where's, okay. And I think Robert Henschel is going to start off, and he's going to actually demonstrate the research desktop, which is a service that his group has developed, and he can go into that more now.
Yep.
So are you going to cut over?
Yep. Okay. Let me just get up so everybody can see. So I'm not going to give an introduction of all the compute and storage systems, and some of you are familiar with it, and who's not really will not retain all the technical specification that I can rattle off. What I would like to, as I said earlier, is give you an overview of what we offer overall, and then point you to some resources that will help you use this in the future. And then I would probably do this at the end, give you a quick demo of the research desktop. Because it's particular for you, where you said you have some of the long-running things that take hours to run, but you're doing it not on a central system. We can come up with a software solution that will allow you to do exactly the same thing you're doing now, but doing it on a remote system. So you can use your system for whatever you normally do, and can do more of those in R or Python or in the same software environment. So our flagship system is Big Red 2, which I think is on the next slide, debuted as the 46th fastest supercomputer in the world when we bought it in 2013. By now, it is no longer on the list of the 500 fastest machines, because other universities obviously bought machines as well. Together with this, we have a number of storage systems. The data capacitor 2 is something that you should look at, because it will give you a temporary space that is available on all the systems, and it doesn't have the limitation that the home directory has, also from a performance point of view, and some other storage systems from it. And then I will show the research desktop at the end. And if you have any questions, by all means, interrupt me. Since some of you mentioned the high memory need, Carbonate is a system that is not super large. It has about 70 compute nodes. Karst has 250, up to 300, depending on how you count. Big Red 2 has 1,000. So Carbonate is by large the smallest system, but every compute node has 256 gigabytes of memory. So this is if you're running a job on a system where you ask for a whole compute node, you can use 256 gigs of memory. There are eight 512 gig nodes.
Yeah, I think so.
And that is it. I mean, if you need more than 512 gigabytes of memory, talk to us. Tom can help you out with an allocation on, for example, the Pittsburgh machine, where it can go up to, I think, 2 terabytes. 12 terabytes?
Is the largest.
Yeah, there is no algorithm should be 12 terabytes.
We haven't had an opportunity to use it yet.
Yeah. And then I'm going to also show at the end the supercomputer Pathfinder tool and HPC Everywhere. So this is the research desktop. I'll show at the end how you get to it. But the point is, you basically have something that looks like a regular graphical desktop in a window. It is Linux based, so it's not Windows terminal server as you would know from a Windows environment. It runs the same software stack as Carbonate. So anything that you can run on Carbonate, you can also run on the research desktop. It has all the most of the third-party applications installed, like MATLAB, SPSS, Stata. We have RStudio on Red. We have Jupyter Notebooks. We have the regular R interpreter, and then you also have an actual file browser, which will allow you to use your mouse to move files, which I know seems revolutionary, but it really is for supercomputing. It's quite revolutionary.
A side note is something we actively do is to help people get applications on. So if there is an application there, talk to us.
And we also have, specifically with the research desk, that we have the ability that if we, for example, have you on Skype or something, we can look at your desktop with your permission. If you have specific problems that you would like to show us, this is something that we can do with the research desktop. Briefly, Exceed. I'm not sure how many of you are familiar with Exceed. It's an NSF-funded consortium that has as its members a lot of the national supercomputing centers like the Texas Advanced Compute Center, San Diego, Pittsburgh. Indiana University is a member with Jetstream, which is what I'm talking about just briefly in the next slide. But the idea here is you can apply for compute time on Exceed. So if you have the specific need for specific GPUs or you need more compute time, you can write an allocation proposal, which is reviewed quarterly. Which is reviewed quarterly. The advantage for a new research is we do not require allocations on any of our machines, right? So we do not ask you for justification of what are you running on the machines, how long are you running, does this make sense what you're running. You create an account and you can use it. Most other universities do not operate that way. You have to either buy into the system or you have to write an allocation proposal. We find that a lot of IU researchers are perfectly fine with the systems that we make available and don't really need to go to Exceed. But there are specific, if you have a long ongoing need, there are machines on Exceed that are like a factor of 10 bigger than what we have. And if you have those needs, just talk to us. We have one of the staff members in research technologies is the campus champion, which is a person that basically can help you write allocation proposals for this.
And then they have to be renewed every year.
Yeah, and that's.
But there's startup applications that are a paragraph and will give you a feel for what the system will do for you.
Yeah. One of the novel resources in Exceed is Jetstream, which is basically an educational cloud. It's the first cloud system that the NSF funded to not do research in clouds, but make cloud resources available to domain researchers.
And that is at IU in our data center. That is our project. So
yeah, this is research. It's a research technologies project jointly with the Texas Advanced Compute Center. So half of the machine is here, and the other half is in Texas, which also gives you high availability on the cloud. And this is on all of the other machines that we operate. You cannot be a super user. You cannot be root, right? You can do everything that a normal user does, and if you need root privileges, we will politely tell you that sorry, you can't make that happen. On Jetstream, you can be root. So you basically get a virtual machine just like you would get on Amazon, and you can do whatever you want. Or better or worse.
And Tom, are you going to show VM images when you do your part?
No, I'll say something and just.
Okay.
So this gives you more control over your environment. If you want to run a very specific application environment, that requires a very specific version of Linux, for example, or you want to stand up a science gateway that wants to run a web server, and you want to serve web pages to the world. We provide limited support for that. So by all means, reach out to us and we can help you with this. But this is really an environment where when you get the virtual machine, you can do whatever you want.
It's yours.
Let me say one more thing about
Yeah.
Use case for Jetstream that my group has been using. They're great for teaching workshops or classes. You can design an EM that has the R or Python or whatever resources in it. You can then clone it 30 times and give each student their own VM, which is pre-set up with data sets or applications that you would need. And compared with having each student download applications onto their laptop, which is always a disaster, it's proved really useful. And we'll help you figure that out.
These fellows don't have to teach, they get to focus on research.
They're all research,
Yeah.
all the time. Yeah. 24/7.
And I assume you get access to the slides, so I'm gonna walk through those. We have a number of software offerings. There is IUware, if you are aware of that, where you can download specific statistic and mathematics applications that are provided by a group in research technology. Same goes for GIS applications. We make most of those applications available on the research desktop and on the central supercomputers as well, if they are appropriate. And then we also have IU Anywhere, where you can run specific Windows applications remotely, but I don't think you have the need for that. And then Tom can talk
On your
about,
laptop if you want.
Tom can talk about the NCS software that we offer through the same venue. Yeah, let's not do that. Redcap may be interesting as a tool that is run by Research Technologies to do data capture for EPHI data. So the biggest users that we have come out of the medical school in Indianapolis, where they basically make surveys for patients that they take, certain times a week, or clinicians use it to just track certain studies. So this is a tool if you want to capture EPHI data through the web, for example.
What does EPHI stand for?
Protected health information. So, or
Electronic protected health information.
yeah. So it doesn't really it's as most of our other systems, all the systems that we have are aligned to the HIPAA guidelines. So if you need to work with restricted data sets, you should probably reach out to us with questions, but the systems can enable that kind of research.
And I just want to point out that this is not just for EPHI data. So if you need a survey tool or a research tool where you can gather information and you can work with that information, you can download that information, that tool works really well. And the support for it is right here at IU. So it doesn't have to be, that's our main users, are people who need it because it is regulated for EPHI, but that doesn't mean that it can't be used for other types of data.
I think there is a storage limit though, isn't there, on Redcap? I don't know, I don't remember what it is. Anyway,
Yeah.
It's a tool, it's there, it's available, and health is also available.
So it might be of interest to people who are collecting survey data.
Absolutely. Yeah.
It is a survey tool. You can build surveys in it. You can,
Mm-hmm. The data is on the
Yeah,
back.
and the data can be exported either
Yeah.
to a Box Health account or to any of the research technology store systems, and then you could work with the research desktop in R.
If your issues are, if like there's no privacy issues, just to try and understand.
It's like plain vanilla.
Yeah, so my question is like, can you say, like, why would one want to use that rather than just making a Google form?
No difference.
Okay.
I mean, the Google form will give you more control over what you do, and the data will end up in a Google table, for example, which for most people is easier to use than the Redcap tool.
Okay.
That is correct.
So Redcap gives you a level of security.
Yeah.
And it also gives you some support. So if you do not want to do the Google form yourself,
Yeah.
you can work with us to design the survey for example.
I think one of the nice things about using Redcap over Google is that, I mean, the Google data, you don't own necessarily that data. Correct?
Yeah, sure.
You don't know what
That's
Google,
true.
what Google is doing with that data.
Yeah.
Whereas with Redcap, you know, if it's something that you don't want anybody else to access, I mean, that's.
Yeah, I mean, if you use that Google tool set, then you apply, you agree to the Google policies.
Right, so that's one thing I would throw out for any researcher is that I personally would choose Redcap over Google just for that fact that you have that extra level.
And I don't know, like sharing wise, is it easier to share in Redcap?
No, it's much easier to share the Google.
Okay.
Richard was mentioning that they're working on an aggregation tool set.
We're working on ETL
Yes.
project, which will then soon make it easier to share the data out of Redcap, where you can basically specify certain tables and it'll dump it to you in a Excel file or a CSV file or whatever you want it, or even into another SQL database.
And does Center for Survey Research work in this platform, or is that sort of?
They have their own
service?
environment they work in,
Okay.
which is like a hybrid, as I remember it, of 2 or 3 different things.
Yeah, so no relation.
Okay.
I think they use Qualtrics for a lot of stuff.
They do, absolutely. Kevin Tharp, we work with him through this same surveys.
And I may have made it in 10 minutes, maybe not. I don't know.
You're okay.
So I'll turn over to
We
this.
started early.
So do you have any questions specifically for Robert about any of the things that he went through? I feel like we need to stop and ask questions after each section because by the time we go through the next section, you might have lost your questions. So do you have anything specific or general?
Yeah, for the research desktop, I don't know if you guys are gonna come back to that.
I want to do the demo. If I do the demo now, I eat into Essen's time, which seems unfair.
But you're gonna do it at the end.
We'll do it at the end.
Yeah.
Yeah, but ask.
Okay, my question is, so does it remain active? Like,
Yes.
can you shut it down and go back to it?
Yes.
And the same session is still going?
Yes. So we do maintenance about once a month on a Sunday. We will hopefully skip maintenance on November. But if you open up the research desktop and, for example, you pull out MATLAB and you have a long running script, there's 2 ways to terminate it, right? You can just close the window, or you can actually say log out. If you say log out, it gets terminated. If you just close the window, it'll run until you come back to it.
Okay.
You have to come back to it within 7 days, which is generous. So if you can manage to log back into your session within 7 days, your script will have run to completion, assuming it will finish.
Even just to look at it and then close it again?
Yeah.
But you
Yeah.
can't archive.
Say it again.
You can't archive your VM with elements.
Oh, that is the research desktop.
Oh, right, sorry, I missed that.
But that is similar on Jetstream. Okay, would also run. But for the research desktop, as long as you log in just for like 5 seconds to look at it, it will run for up to 30 days, basically. If you log in right after a maintenance day, you have 30 days. And if we skip the November day, you can actually make this.
I don't know if this is quite the right session, but I guess this is a broad question about GPU computing. Like, are there different quotas for that? Like, how fancy does your code need to be? You know, like I know things are changing very rapidly with that. What's the?
Yes, I agree with you. That is a detail-oriented question. We're going to chat at you.
Okay, sure. Yeah.
His group optimizes code. They work in the environment, so
Okay.
they know a lot about it.
Great.
Great. I left a few cards on the table if you want to get a hold of you later.
All right, I'll go ahead and breeze through a fairly large number of slides here. And the idea here is to give you pointers if there's anything that catches your attention for for your research, then we can talk more about it in detail later on. So my group, Research Data Services, provides data management and research workflow help. We particularly focus on scalability on our HPC systems when it comes to text analytics and scalable photogrammetry. And I'll talk about these in a little bit detail. And we also provide help on the Stampede2 system, which is another Exceed resource that anyone in the country will have access to. And Stampede2 is one of the larger systems that goes up to 18 petaflops. So if you stumble across like a very large HPC sort of problem that Robert says, well, go there, you can talk to us. There are a couple of services I mentioned when I met you that my group runs. One of them is the Radar's sensor data enclave. So if you get a restricted data set from a vendor like Bureau of Labor Statistics, Department of Education, or anywhere else like the Opinion Research Center from Chicago, you would have the need to put that data set under lock and key, which is quite hard to do. What we have done is we have provisioned the VM by means of a data custodian. We put that data set on the server and give you access remotely with all the necessary analysis tools. You do your research there, and then when it comes to time to extract your research results, publish them, or use them, you go through the data custodian and you write, okay, there's you have abided by all the rules and regulations of the user agreement, and you get your results back from the server. The research database complex is our service that provides MySQL and Oracle relational databases to you. You just say, I need a database, we set it up for you, and we set up the accounts, and we give you the keys to the database, and we also provide you, if you need it, consultation on how to manage the data, build your data models, and do advanced applications on that. We have some interesting data sets that drive research and websites out of RDC. I pointed out the NERMI database. It's one of our clients runs that. And that picture is actually another thing that might be of interest to you. It's let me get this right, it's the risk screening environmental indicators model that one of our clients works on. So they collect much data from all across the country through EPA and publish quarterly run a lot of analysis and publish it in the EPA site through our systems. So there's a ton of interesting clients that might be relevant to interact with. The other responsibility that I have is with the Advanced Visualization Lab. And we try to provide consultation in facilities and services out of AVL for a wide spectrum. You may be a researcher doing custom solutions, custom visualizations, or you may be just like giving these cardboard Google things to kids to learn from your research. We provide an entire spectrum. And one of the facilities that you might recognize across campus is the IQ walls. These are large tile displays. We have them at several locations all across the IU system. When it comes to sharing information out, where the size really matters, you want to display a lot of things all at once, compare them to each other, and have the really detailed resolution. The IQ walls are really good for that. And it allows for collaboration right at the wall or maybe across sites. We provide teleconferencing on all these systems. The important thing with this is it's really easy to use. And it's just one Windows PC, and you can run any application on that Windows PC. So nothing special is required. You only need your ADS account to use any systems. And we have to date built 19 of these displays. 13 are currently active at several locations. Some of them are touch capable, so you can actually interact. Actually, several people can use the touch feature to interact with these displays. And some of them are 3D capable, so you would put on those passive glasses and display 3D content to a very large audience as well.
And just to comment that Matters Museum is a partner with the RI, so that's a particularly friendly connection there if you're interested in it.
I think for the initiatives that you're all working on, it would be really interesting to be able to have some visualizations or have some of the data once you acquire it, and then work with the Advanced Visualization Lab to display it on campus. Since it is a campus, a McRobbie initiative and all of that, I think seeing some of those things around either Bloomington or the other campuses could be really interesting.
Yeah.
A great way to use that advanced visualization along with the research that you do.
And these are available, most of these are available publicly. Wells Library, the Scholars Commons is, short walk from here.
Luddy's close.
Luddy is closed, Global International Studies is closed, of course Matters is closed. So you have a large number of these available to you, and most of them are publicly available. Another interesting feature you might use is the reality labs. This setup I call a reality station. It's in essence a really souped up PC with large memory, a good CPU, and a really good graphics card, and head-mounted display for to have that immersive VR experience, and a couple of devices, input devices, so that you can interact with the virtual environment. And you see students doing whatever they are doing there. There's a ton of applications preloaded that they can use. And also the Steam is actually an app store sort of thing for these VR applications.
My daughter and I used this at the Science Fest last weekend to do virtual pumpkin carving.
Wow. Way less messy.
Very good. Way less messy.
And safer.
That too. Yeah. A colleague of mine ran the knife straight through his hand
In
2
VR?
weeks ago, doing not in VR. Should have been VR. Yeah.
So there's a lot of applications, and it's lovely, these things. But another point of these is you may want to use VR, but remember these are really beefed up PCs. So these are really powerful PCs out there for your disposal, and there is 30 of these labs and classrooms available across IUPUI, Bloomington, and IU East.
Media and our partner Architecture and Design are both partners with us here.
Are most of those reservable? Do you have to reserve them in advance?
Some you can reserve, yes.
Yes.
So that's a really good resource for you to use, even though if you don't have any VR content, there's a lot of good uses there. We have a couple of flagship facilities out of AVL. This is our 8x4 tile display up in the it's quite a site. It's in ICTC 403. If you're ever on IUPUI, go visit. It's open. It's quite a site. I mean, it's like I was thinking, well, it's a large display, tile display. What I've seen we have in our building at a 6x4 wall. It's nothing to it. Well, you start walking across, it takes a while to go across, from one end to the other end, in all really 4K definition. So it's quite something. And the nice thing with that is we have over the last decade, we have sort of perfected the recipe and how we put these displays together. We have come up with a reconfigurable way of displaying these things. So according to your, whatever you want to display, we can form these displays in concave, convex, standalone formats, and you're actually taking half of a similar display to the supercomputing in 10 days.
So the mobile, you can.
Yes.
Move around.
This is kind of a configuration.
They're not installed.
One of our questions at the supercomputing conference was, because they wanted to show the configurability of them, we're like, so people can stand and watch, and they're like, no, we would like, when the booth shuts down at night, we would reconfigure it because it would take like 45 minutes or so. And then when people came by the booth the next day, they'd be like, whoa, that's completely different than what it looked like yesterday. So they are configurable, but not on the fly, configurable, yeah.
I mean, you can put them side by side in 2 minutes, but then you have to really align them so that it looks perfect. So otherwise it looks like, it doesn't work. What else do we do in AVL? We do a lot of information visualization, scientific visualization help with virtual reality, and nowadays augmented and mixed reality has become a real thing, where like you mix like the reality with a lot of other content, augmented reality, and finally you can really immerse in the virtual reality. And I was just in a digital heritage conference over the weekend, and well, actually, it was Vint Cerf who was making the argument. Vint Cerf is the co-father of the internet as we know it. So, well, it's not really virtual because, like, you experience it. So it's virtual reality is actual reality. We're like, oh yeah, that's true. Anyhow, so the text analysis, we provide cyber infrastructure for arts and humanities. We do a lot of stuff with text analysis. We have experts on hand who can help you with text analysis problems. If you want to go through scientific journals to find things, see some trends, do an analysis of what is becoming important in a particular field, text analysis might be something to do. And again, a lot of you are using R, Python, so it'll be really easy for you to do that type of research. And another thing we support is digital arts. And we just recently met Maria, if you know her. You must. And really interesting, you really want to, if you want to have a voice for your research, have, just ordinary people understand it, connect with it. Arts is a way to do it. So it's, she's doing work in that area. And we have Margaret Dolinsky, she's doing virtual reality in art, really interesting things. This is sort of interesting. These are actual live leaves, and by some laser method, they actually have these shapes grown into the leaves themselves. So it's really cool stuff. Moving briskly along, 3D digitization. This is an area that's getting a lot of attention lately in all fields. How do we capture reality, the things that are around us, to actually collect information from reality, analyze it. And we have worked a fairly simple method and workflow to figure out what technology you need to utilize to capture information and analyze it. You can model things, you can, if you are interested in the internal structure of things, you can do these micro CT scans, and I think Terry mentioned that. And photogrammetry is all the rage lately in all fields that we have looked at. That's basically building a 3D model from photographs. And we have also ways of doing scanning with LiDAR and structured light scanners to model objects in spaces. Photogrammetry, it's, I'm not going to talk in detail to this, but this is a site, an archaeological site with a large surface area. Alex Badio, someone from the Soig, a grad student, he captured 14,000 pictures with a drone, and using Carbonate, in 30 hours, we were able to entirely model this site.
We have a drone.
Awesome.
If anyone has a site.
Yeah, there's like, you can do pretty much anything, like, get a permission for campus, I guess you might know about that. But, this is cool work, because even with like, anything that you can put on your desk as a PC, this would have been almost next to impossible to do in not even weeks. So, thank you, Robert. And
I do it all by myself.
oh, and we have captured all the statues of IU. So we have models of all our statues. And actually, Todd Langland himself, we were really worried whether he's going to hate us or like us to model his creation. Well, he loved it. So like we gave him a 3D print of his Ernie Plas statue, right, by
Journalism.
yes, the sample case, yes. All right. More technology. I think this is my second to last slide here. You can use a structured light scanner to scan a bunch of different things. For larger spaces, you can use what's called this Matterport device. So we have done the Ray Bradbury studies, and then you can get that gigaplan image where, like, you have really zillions of pixels on your image for detail analysis. We support all kinds of data workflows, stuff that people capture. We help them to put in context. We work with Dr. Bellici, Mr. Shorty here. He lost to cancer his mandible, and using our scanner, they have built him a prosthodontic jaw, and well, I mean, now he's like functioning normally. This is the Bethel Church in Indianapolis. Well, I don't know whether we could call it environmental change, but they were going to demolish this place, and so a faculty member, he went and LiDAR captured the entire space, and these are actual captures. I mean, so is this one. So they texture mapped and everything. So this church is preserved for posterity in digital format. And that clarinet mouthpiece, it's from a German Jew who escaped the regime, came with this wonderful clarinet. No one figured out why it sounded so perfect. And eventually they did a CT scan of it and figured out its properties and all that. And, well, I couldn't really figure it out. They just remanufactured it. And that's all I have for you guys. If you have any questions, I can take them now or later, and I have plenty of time.
Good.
Thanks.
On Doak.
I'm going to be pretty fast about this. Invite anyone to talk to me later. My group is NCGAS, the National Center for Genome Analysis Support. We are a management group within Research Technologies. We're also a center within Pervasive Technology Institute, but this is also a specific grant from NSF to maintain the center. And so we provide national cyber infrastructure for biologists doing genomics. And my people here,
Animal lovers.
Animal
lovers all around.
Yeah, don't tell them that. Is emphasize that we are all biologists who got bioinformatics, or maybe vice versa, but we, or one of us, can pretty much always talk to a biologist about their project. So why genomics? Well, all the omics are becoming essential, much used in ecology, cancer treatment, everything in between, physiology, and it's computationally demanding. I mean, a lot of genome assembly, metagenome analysis, you can't do on a desktop. And so, because there's many new researchers whose specialties lie elsewhere, I mean, they're physiologists, they're behavioralists, or they're conservation biologists, they don't know about the computational resources that are available to them. And so our job is to put those two things together. IU has always had a lot of genomics, so Research Technologies has been supporting people doing genomics for a long time. And we get money from IU to help
Support IU researchers.
But NSF also agreed to a grant that pays us to help any NSF-funded researcher in the country who needs help with genomics. And at the moment, we've got most of the states under control. The High Plains are a little difficult, so if you know people in the High Plains, let me know. So our primary goals are to provide bioinformatics expertise through consultation, maintain a curated set of genomics applications, find access to HPC resources, Mason, bridges at Pittsburgh, Jetstream, and other places through Exceed. Galaxy is a menu-driven interface for line command applications. So if you're not comfortable in line command, you can come to Galaxy and run many of the same applications. And so we wrap applications for Galaxy. And then we pursue outreach to biologists. We do trainings, we do workshops, both here and other places in the country. We have a very popular workshop on RNA-seq de novo assembly at the moment. If anyone's interested in that. Right, and so we serve IU researchers, NSF researchers nationwide. We work with cancer researchers as a partner on NIH grants. And this is ITCR, Information Technologies in Cancer Research, which is a study group within NIH. And then we'll work for pay too, and peanuts even. So people write us into their grants as providing services. I think, is the field station here someplace, or did it disappear?
The what?
There are two on field stations. Don't worry.
Maybe he suppressed them. They may be in there, Tom, if he's hidden them.
Let me it's only
Just
two
talk
slides. It's only two slides. Because the program officer at NSF asked us to, and because we are basically biologists.
It was the bio director at program officer, was it not? Yeah.
He was our program officer.
Yes.
Who also manages grants to biological field stations. And biological field stations or other groups doing field research frequently don't have very good access to cyber infrastructure. They don't know how to get a hold of it. They don't know what to do with it, where to find it. And so we've started working with field stations and going to their meetings and developing tools, a number of them based on Jetstream VMs that can help them. One thing that we've been playing around with, we have student teachers, researchers, is environmental sensors that talk to a little Raspberry Pi, and they can upload all that information directly in Jetstream, or it can be processed, or it can be sent off to be archived. And so if you have field work of that sort of thing, we'd love to talk to you.
I want to flip to the next one, there, please.
Yeah.
So one of the things that Esen and everybody has really talked about is the consulting. And I think that if you walk away with nothing else, that like Robert said in his presentation, that you can at least put a face with somebody you can talk to now. But we provide consultation on all of the different things we've talked about today and some additional things that we didn't talk about today. It really is a lot of services. If you go to our website, I think that's on the next page there, rt.iu.edu, you can get direct links that'll shoot you into the knowledge base directly. In the folder that I gave you today, sort of our 5 service areas are the head categories on the sheet of paper in there that says supercomputing for everyone. And then it's broken down, it kind of goes to our tier 1 services, which are broken down like cloud computing or HPC, different types of consulting. And then it even does a deeper dive on there to take you directly to KB docs to help you specifically on each one. And those are all discoverable in the knowledge base if you kind of know what to search for. But if you're having trouble finding something, like Robert said, it's really important that you know that you can always reach out to us. We don't have the live chat. We do have the Slack channel that Robert mentioned. There is an HPC Slack channel that if that's something that you're interested in joining, that's open to everybody at IU. So, and I think that now what we want to do is give you all time to meet with individual research technology folks in the room to see demos of things that you might want to learn more about, or just talk to people specifically. I know that Robert wants to show you HPC Everywhere and also hopefully Research Desktop. And if you want to connect to Zoom, we could throw it up there so that it's recorded as well. That would be great. Yeah. Are there other things that you guys would like to see or demo or hear more about while he's getting plugged into Zoom? I'm logged in as a host, so I can have you share your screen.
I mean, in some ways, this is kind of the most obvious stuff that might be just read about online, but a quick rundown of the different clusters and to give us like a better sense of maybe which ones we might be can do. Starting with, at least.
If you stop sharing, I can start sharing.
Okay. Let's have to figure out which one is me because I'm logged in twice.
You can use the mouse to click the red stop share too. Or just bring it
There you
to.
go.
You say it as if it was that easy.
Oh, there it is. Yeah, the mouse is, there we go. And if for some reason you can't, I can make you a host. That's a good thing.
So let me show HPC Everywhere. It's basically, the hope here is that we will develop over time a website that will serve as a portal, as a starting point for the HPC users at IU. It's simply HPC Everywhere, .iu.edu. It is in beta as the tag. Oh, no one's pointer. So we basically just launched it a couple of months ago. The Pathfinder tool I talked about earlier is linked from here. You get a link to how to apply for accounts. You get a few other useful applications. Let me show you just the Pathfinder tool, and then I'll talk about the various clusters. So if you know roughly what you're doing, what you want to do on the system, you say, I want to run a Windows application. Let's say no, because that would be really hard for us. I'm new to supercomputers, totally. My application is in R, yes. I want to do this interactively. My application needs more than 64 gigabytes of memory. Sure. Yes, yes, no, no. And then you hit submit. You get at the very top, you get sort of, what would you do? Right now, in Big Red 2, very bad for you. I'm not sure what I did to cause that. But of course, the research desktop comes out ahead. So and then you can change this. Too bad you don't see my mouse cursor. If you go over
If you're new to supercomputers.
Yeah.
You're good to.
So you can basically change the answer,
And it changes the results every
Change
time.
the bars tolerance. If you say, I
It
want to
gives you the right answer.
So you get the answer you want. You can choose message.
Yeah, you can. So if you want, Bigred 2 is a large tray system. It has about 350 nodes with 2 CPUs and 670 nodes with GPUs. If you have GPU-enabled applications, they would run best on Bigred 2. It has the steepest learning curve compared to all the other systems that we have. I would not recommend people start out with Bigred 2 because it's a cray architecture. It has the AP run infrastructure, which people have run at systems like NCAR or other weather centers. Straightforward. For others, maybe not so much.
Robert, would you talk about Bigred 2 Plus, since these are all
Oh,
grand
yes.
challenge
So
users?
we do not advertise Bigred 2 Plus because it's only available to grand challenge users, which you all are. Bigred 2 Plus from an architecture is very similar to Bigred 2. It's also a cray system, has 560 nodes, and we like to give it away, to people who are on grand challenges. We have a web form where you can just apply for it. Hit any one of us up and we can point to it. Or to people who have very large scale needs. So if you need to run a simulation with 15,000 cores for 2 weeks, Bigred 2 Plus is the place to go because there's only a handful of users on the system. And if you submit the job on Bigred 2 and you ask for 10,000 cores, it will run maybe in 3 weeks because the system is powerful. The software stack is identical on all of them. You can run it pretty much any Linux application, all of them, even on the cray systems. Karst is the throughput cluster. It's 250 nodes. It's sort of the easiest one to get started with. Queue wait times should be relatively short because of having 250 nodes. Standard Red Hat 6 operating system. And then Carbonate is smaller and has specifically for larger memory jobs. Carbonate is the way to go. You can also, when you are in HPC Everywhere, you can look at HPC at IU. This will give you some pointers. It will give you pointers to the KB article. It will give you an overview of which nodes are currently busy, which ones are free, which ones are down. It'll also give you the names of the queues, which may be super helpful. It's always hard to do this in the command line. And you can actually also get an idea of how long do I have to wait for specific jobs. So this will give you an idea of if I submit a job and I request 5,000 core hours, history tells me that I wait about 15 hours.
But you guys have consulting to help people optimize their code so that they can reduce runtime or the number of times they
Ideally,
need.
yes. Yeah, so you can always reach out, for example, via the most one. At the very top right hand, there is a blue icon. It's a envelope. You can click on that one. You can submit email. You can look at the slide deck that Rob will share, and just say, here's what a problem I have. We'll get back to you.
For submitting jobs, I assume there's a system where you have to have some kind of file that gives the.
Yes.
I mean, are there tutorials or
You
workshops?
ask all the right questions. So, for example, there is the script generator. If you do that, it will generate a script, for example, for the machine you want to use. So, say you're on Karst. I could not have paid you money for this. And you say you want email sent to you, for example. No mouse pointer is killing it. At the very top, right? If you say I want an email when my job starts and stuff, you can, for example, put this in and say I want to use the Intel compiler and I don't want to use MATLAB. It's not loaded by default. Say I want MATLAB to run with this thing. And it'll generate a shell script here. If you use the research desktop, you can actually copy and paste the shell script straight to your home directory on Karst. This will work we will generate you the shell script for Bigred 2, Karst, and Carbonate. Right now, not for Bigred 2 Plus, since we have so few users, but we will sit with you and write the shell script for Bigred 2 Plus. And then once you have something to get going, you can modify these yourself. And the KB also has those templates.
NC Gas has a lot of trainings, mostly posted as blogs. some of them are genomics specific, but some of them are just getting started in Linux. Structure, all these basics. But since they're sort of aimed at biologists, they sometimes seem preferred.
We have a whole series of workshops called Super Computing for Everyone as well. And so this might be really good for you as a brand new person using HPC. There's one that is just a 2-hour workshop that is an intro to all the systems. My guess is you probably received most of the information today that you would receive in that particular training. And then we have 2 90-minute to 2-hour trainings. One is just about how to use storage on our HPC systems. One is how to use software on our HPC systems. So those might be really helpful. Generally, we have anywhere between 5 and 20 people at each workshop. We hold them in Bloomington and at IUPUI. So for some reason, the date and time doesn't work for you here in Bloomington. It's not too far of a drive to go to the IUP one at IUPUI. And I will be posting those shortly. They show up in IT training. And I can send some postcards over to Eva so that she has them here at the Institute as well for anybody who might want to attend.
Sure, I put stuff up on the bulletin board, so if you want.
And we even have Unix for basics, Unix the basics. So even if you're not that familiar with how to use command line, we have a 4-hour workshop that does that. And then we have some more advanced workshops too. There's an intro to parallel programming. So for those of you who are doing parallel processing, that might be good. And then there's also an intermediate one. And those are both full-day workshops here at Bloomington and at IUPUI. I can send that information over to you. We already had all the ones for this fall, but we do them every year. And eventually those are going to be available as online courses as well. So there'll be Canvas courses that are pushed out through the e-learning website that's at iuexpand.iu.edu as well. We'll be pushing those out there.
So we're not quite there yet.
Not quite there yet. Yeah, we're doing some test cases right now.
Yeah, there's a way to look at your jobs in a graphical fashion instead of doing it on the command line. Depending on why jobs are not running, you actually get a relatively decent explanation here on why the job's not running. This one, not so much. This one says look at details. If you actually do that, you have to interpret JSON code.
So one of the challenges that I had, the questions really about where should I get information. So like I was writing some scripts to, or some submission, whatever, PBS scripts. And there's all these things like, when you ask for your allocation, not that's the right word, of like, how many cores and nodes and time and whatnot. And so like Carbonate wants a VMAN and others want PMAN. And I was like, where can I find like what you guys need for these particular ones? Like I felt like I couldn't find like.
So the KB has one article for each system. Right? So if you say there's Carbonate, and then in Carbonate you would look at the run jobs part, which is this one. Yes. And this will talk about the specific. This will give you a certain info.
Yeah.
It'll give you most of what you want.
Yeah.
I think it's the right one. If you read through it clearly, it talks about the fact that Carbonate does require the VMAN feature, right? Because we allow multiple people to run in the same node, in order for them not to, for your job not to consume all the memory of somebody else. We have to ask for memory. The problem is this has downstream consequences. Explaining it really in depth is hard. So, but this is your best bet.
Yeah. So I looked at some of those, and it was just confusing to me to know, like, well, why can't I ask for a PMAN here or something like that?
In that case, you drop into the Slack channel and you ask.
Okay.
Or you send it.
I was wondering if what might have been helpful to me is like because I think you have it for some of the queues, the queue restrictions on different ones, something like that for something like those. Which systems need which parameters? Like a nice sort of structured thing.
I will take them back to the documentation.
Okay.
How's that?
Thank you. Yes.
So let me just quickly at the end show you the research desktop. There's a KB article about it. There's an application called Pinlink that you can download either on the internet or from IUware. It currently does not work in the browser. We're working on making the research desktop available in a web browser, which at that point would work on an iPad or Chromebook or on anything that has a web browser. Right now, we're not there yet because the web interface is currently broken in 2-factor authentication. And since we have to do 2-factor, this is a no-go right now. But we hope to have this done in the January, February timeframe.
Because you want to be able to work on your phone while you're standing in line at the grocery store. Because
Yes.
we all didn't work enough on our research. And
Yeah, right now we cannot make that happen for you. We're sorry. But Q1 next year. So you put in your regular IU username, passphrase. All of this is documented, right? You don't have to. It's karst. It's desktop.karst. The other one is desktop.red.iu.edu. And you have to do the 2-factor thing.
Take one step.
And then, so this is the session I had open. I have opened this session open for quite some time, but this is what you said. Basically, you go back to where it is.
Okay.
And then it's a regular Linux desktop. So at that point, you can run Jupyter Notebooks, MATLAB, or Studio, SATA. Most of the applications take a little bit time to start up because our file system that we run the application on is not the fastest, but it's a different file system to where you put the data. And then you also have a file browser, which is really, because file movement with copy on the command line or SCP is not the easiest way to move files around for most people. So this gives you access to your home directory, and then what you asked about. Every system has /n/. Let's look at /n. This is there's a DC2 directory, and in that DC2 directory,
That's the data capacitor.
that is the data capacitor. There's a Scratch subdirectory. Yes, no, maybe.
And you can't see them on the left too.
Yeah.
DC2 Scratch. There it goes.
I'm not going to go into the Scratch subdirectory because there is about 5,000 subdirectories there, but every user has a subdirectory in Scratch. So if you look at the path, it's /ndc2 Scratch your username, and that's where you put anything that you need for computation.
How long can things stay there?
Things stay there if they are untouched for 90 days. And then if you access them, they stay longer. You can also request a project space, and then it's 180 days. However, this will change. PFAC itself has a 2 petabyte space that is allocated just for your grand challenge. And we can talk about how you get to that separately.
But your home directory doesn't, it's not, that's just a.
Home directory is permanent. Yeah. And then let me just quickly show you the research desktop. Because then I can show you the Slack channel as well. So the research desktop is a little bit more modern. We have a newer version of the user interface. And then you can straight ask questions. So I have an icon on the desktop that says, ask us a question. And you just put that there. It will do nothing other than send us an email. Then you will get the reply in email. It's a ticket, right? But it's an easier way for you to just open the ticket. And we have a direct link to HPC Everywhere, which does nothing more than open a browser and run the web page there. And then we also have a link to, if you go under applications, we have a way to mount your box directory on that system. And there's also the IU Slack channel, which is really just a link to the web browser again.
So does that mean that you can, from for example, Carbonate, you can directly navigate to your box account?
Yes, you can.
Find files and move them to your Scratch, for example?
Yes. Do not compute against it, right? Don't take MATLAB, navigate to Box, and run an M file.
But just be a way to be able to like access your files, move them to scratch, run your computation, and then move the results back to your box folder.
Yes. So I can let's see if I have this all set up. There's a little setup process you go through to register that specific application, which you have to do every 60 days or so. But then once this is done, you basically open the file browser and you have Box as a directory. And you can actually navigate to it on the command line as well. It's still sort of beta. It doesn't always work, but if you copy things back and forth, that works reliably. Just if you take R and you direct it to a script that sits in Box, then it's just experimental. Okay. But we get a lot of requests from users who have their data in Box. And then they will download it to their Windows workstation and then they SCP it over and then it needs to go back and not super convenient.
What would you recommend is the best place to hold data to then run computation on it?
Your 2 petabyte space on DC2.
So do we all have that by default?
There's a shared 2 petabyte for everyone in PFAC, and we should find a separate place to talk about that. It's not currently available since it's on the successor of DC2, but right now the best space for you to put anything you want to compute against is DC2.
What's the address if you want to SCP to DC2?
You SCP to the login node. Basically, you SCP to cars.uits.
And then how do you go down?
And then you have.
Just the dot.
So, what application do you use for SCP? The command line?
Yeah.
Okay, that's fine. So that would be, for example, this is a way to copy the R file to my home directory, right? So if you do n dc2 scratch Henschel,
okay,
that will work.
I got you.
Or WinSCP or FileZilla or anything.
Yeah,
the problem here is you have
it
to
was
do
always dumping me at the home directory and I had to go
Correct.
below, but this will work, I guess.
Yes, this will work. The problem is you have to do 2-factor with SCP.
Yeah.
Right. So here's the if you do not want to do 2-factor, you have to use public-private keys, which will get rid of the 2-factor requirement, as long as you have a passphrase on your private key ring. So I hope that everybody has seen those announcements. If you have questions about this, send us an email. We'll point you to. There's a web form where you basically say, I acknowledge the risk that I'm bypassing 2-factor by having the second factor be a passphrase on my private key. But nobody really wants to do it 15 times a day. I can understand.
Yeah.
So we have about 6 minutes. I think everybody's willing to stick around a little while longer though, but is there anything that's super pressing that's on your mind that would be helpful?
What about for storing things just kind of for longer term storage that you don't need to access all the time?
Like archival.
Okay, archival.
Yeah,
So
we have.
Box is one, and the other one is the scholarly data archive, which is the tape archive.
Sorry, what was the second?
The SDA, the scholarly data archive.
And that's run by us, UITS Research Technologies.
And I can go.
And the data's mirrored,
That,
so it's in 2 locations.
Okay.
they don't we have some scripts that make it easy for you. But
Yeah.
we on a schedule if you want like to. Then we can help with those workflows as well. And I have a staff member who's looking at those type of things.
Is there one you would recommend if you have multiple users, like trying to go get the data, then bring it to whatever computer they're working on, do some kind of analysis, and then put it back up for storage?
Right. So when you say you don't need to access it very often, like
Like you might do
define
a
that.
batch, yeah, like so for these micro CT scans, I wanna have storage of all the raw data files, but then sometimes we'll be pulling them to work on them. What would you recommend?
SDN would work
Yeah.
for that case.
All users here by you?
Yeah.
Okay, good.
How big are those data sets that you're working with?
Well, I filled up a couple terabyte, like 4 terabyte hard drives for all. So to me, that's very
So
large,
that-
but maybe not to you.
No,
Yeah, so,
that's SDA kind of data.
yeah, okay.
That you would have a really hard time to do that on box, for instance.
Oh, okay, all right.
So it's SDA, like, even though, like, the uploads are gonna be like, super fast for you,
Yeah.
because there's a disk cache, but, basically, whatever you throw at it, instantly almost. Reading it back is going to not be instantaneous, because it's a 35 back, but, it's not like, you will have it like, in short order. The transfer time is probably more noticeable than the wait time. So it will, won't really, affect you as much.
The nice thing too about the SDA, I don't know if you ever use the ScholarWorks through the library. It's a repository where you can keep your research, you can keep publications and things like that. And the SDA is the backend for that. So the SDA would allow you to, as you get research completed, if you need people to be able to access data sets, you can create the DOI to point people to data sets or to point people to your publications and presentations, which is very handy. So that's something Box doesn't really do. When you can do it, you can share a Box file, right? It's part of your publication, but the SDA would be a more persistent way to do that. And it uses the DOI, which is what people are used to seeing.
Through ScholarWorks.
Through ScholarWorks.
So is it possible to have, for example, data up on the SDA with an associated DOI that remains even after you've left the university? Like for like a longer term?
Persistent, you're saying, is it persistent after?
Yeah, so that people could still access it,
Right.
for several years.
I believe, because once it's in ScholarWorks, it's permanent. The space is there and it's there forever. That's the intention of ScholarWorks. And that's really a library service. Our hardware enables that service, but the libraries really run that. But that's the whole intention of ScholarWorks.
But if you have data sets that you want to keep on the SDA that you want to remain persistent, I would suggest that you use group accounts for that rather than an individual researcher account, because individual researcher accounts on SDA may go away
True.
after you leave the university, but a group account could be assigned to another researcher who's at the university after you leave.
Okay, so I would just be over time adding a different person or somebody that's like managing it.
Exactly. And you should probably do the same in Box. Really, that's a good way to make sure that if something happens to a researcher, if they go somewhere else or something worse happens, then your group can still access the information that you need to continue the research.
Okay, I didn't know that.
And for RDC, the database service, of course, you have to give us a group account as the owner of the database.
It can't be an individual asset.
Right.
Yeah, and ScholarWorks is made to house data sets as well as publications and papers. Anything related to your research.
And you could set up the Grand Challenge Initiative as they sort of have
Communities, they're called communities.
within
Within
ScholarWorks.
ScholarWorks.
So you can, I don't know if you can put things in more than one community. I don't think you can. You'd have to have
Because it'd be
you'd have to duplicate
multi-pointers.
it. Yeah,
Yeah, you have to duplicate it.
But you
The
can
only
set
thing
up-
about ScholarWorks that I think is kind of inhibiting is that from the outside discovering it, it's not as easy because it's more an IU resource facing inward to IU. It's like an internal IU library of collection of information. And most people Google things today, and so that's usually the way they discover them first. And IU ScholarWorks is not inherently that. And Tom is looking at me like, what are you talking about?
Well, because it does create a unique handle. So in any of your
The DOI
own,
would
right,
be.
in any of your own publications lists, if you have your own big tech or whatever, you could use that handle and then you're taking them directly
You're
to
pointing
that.
right to it. It's a
So
DOI.
in that way, it's very discoverable. But yeah, just to go to ScholarWorks and search for somebody's work,
Or just to go to Google and search.
it's a lot more difficult that way.
And some of you mentioned geospatial, that's another service that's run out of RT as well. Indiana geospatial portal.
Oh, yeah, because you guys are all about the state of Indiana.
Yes, so that's
I love the maps.
that's
on
like
there. I love
a
them.
really great resource as well. And at the back end of that, all the data is on SDA. All the that map data is on SDA.
Yeah, that's a
Are you
project.
guys
What
gonna
was the
go?
name of the map?
Indiana Geospatial Portal. That's right, really geological services.
Geological and water
Yeah.
survey.
Here, I do.
So I don't know if you're aware, but
It's been around a long time. That's
there is
big
a
project.
geological association meeting happening at IUPUI all next week. And there's a big, are you guys? There is a big IU booth, so you could come and talk to some of the GIS folks.
And get more information,
Yeah,
Robert.
and you might see me there the whole time.
Indiana Spatial Data Portal.
Yeah.
That's the service we have.
Yeah.
Okay, thank you.
Other questions?
Great.
Great, thank you.